So we're going to write our first really useful function now. I'm going to write a function to find the reverse complement of a sequence of nucleotides. And remember, the first thing we do is think about the pseudocode of how we might accomplish this task line by line. I also want it to do something if it comes across an invalid nucleotide. So here's how I solved the problem in my head. Here's how I thought that we might achieve this. What I want to do is go through our input sequence and do something for every nucleotide in that sequence. So I know I'm going to use a for loop. I'm going to do something for every nucleotide in my sequence. What am I going to do? Well, I'm first going to check if it's an A, and then if it is, I'm going to do something. I'm going to check if it's a T. If it is, I'm going to do something. So I have this idea that I might use an if statement. So if the nucleotide is A, what do I want to do? Well, if the nucleotide is A, what I'm actually going to do is prepend the complement sequence with a T. So what I mean by that is go through my input sequence in order, and then as I find the complement nucleotides, prepend them to the beginning as opposed to append onto the end. So add onto the beginning the complement nucleotide. So this is just a trick to get a reverse complement rather than a forward complement by going from left to right through my input sequence and going right to left through my output sequence. So if I come across an A, I'm going to add a T onto the beginning of my output sequence. And then I need to do that for every nucleotide that I might come across. So else, if it's a T, let's prepend an A, etc., etc. So this is my idea to solve this problem algorithmically. So I'm going to begin to convert that to Python code, line by line. Open a new text document. Make sure your smart quotes are off, make sure your rich text formatting is off. And the first thing I know I need to do is import sys. And I know I need to import sys because I'm going to be passing some arguments from outside Python into Python. So I want to be able to get this, I want to be able to run my code and say, okay, this time the sequence is ACGCT. And it will take that argument in and run it with that sequence. So the next thing I'm writing in my code is a code comment to tell myself that what this function does, that it prints the reverse complement of a sequence. Remember, to define a function, we use this def keyword. So I'm defining a function called reverse comp that takes some input argument, which I'm calling seq. So I'm defining a function called reverse complement that has one input. I then have a colon, a new line, and an indentation. So this is where I then write my function code. So what do I need my function to do? Well, first I need it to define an empty string, which I'm calling rc_seq, which will store my reverse complement sequence. So I'm starting with that empty, and I'm going to fill it with values as I go through my input sequence. And then I want to do something for every nucleotide in my input sequence. So that's where this for loop comes in. So for nuke in seq will set nuke equal to the first nucleotide in my input sequence the first time, the second nucleotide in my input sequence the second time, all the way through. Okay, so I want to do something for every nucleotide in my sequence. What do I want to do? Well, the first thing I'm going to do is check whether my nucleotide is actually a valid one that I'm interested in at this point. So if my nuke is not in AGCT, let's print that it's not a valid nucleotide. So what does that mean? Nuke not in AGCT will be true if the nucleotide it's got is either an A, a G, a C, or a T. So nuke not in AGCT will only be true if we have a letter that isn't one of those four letters. So if the nuke is not in AGCT, I know I have a letter that's not one of those. Perhaps it came across an X or something. And in that case, colon, new line, indent even more, I'm going to print that whatever that nucleotide is, so I'm going to print that some string is not a nucleotide. And then I'm going to substitute in the nucleotide into that print statement. So print some string is not a nucleotide and substitute in nuke into that position. So it will then say X is not a nucleotide for this purpose. So be very aware of the indentation that I'm using as I'm typing this in. because that's what's telling Python what to run when. So everything starts on the left-hand side of the page. Then I define my function, and all the code needs to be indented under my function definition. When I go inside my for loop, so any code that I'm doing for every nucleotide needs to be indented again under the for loop. Bless you. And then I have my if the nucleotide is not in AGCT, and then I'm indented again. So this print statement is only run if my nucleotide is not valid because it's indented multiple times. So this code is done every time we run the function. This code is done for every nucleotide in our sequence. And this code is done only if it's an invalid nucleotide. So be aware of the indentation because that's what's telling Python which code to execute when. Okay, so we've dealt with the case where we have an invalid nucleotide. So let's begin to deal with the valid ones. So I have if the nuke is not in AGCT, let's print that it's not in AGCT. Then I have an else, which says, I know now that I have a valid nucleotide, so I have a colon, a new line, and an indentation again. Then I check which nucleotide I have. So the first thing I do is say, if nuke is equivalent to A, remember these two equal signs is the logical operator to check whether two things are the same. So if the nuke is A, let's do something. Again, be very careful with the indentation. We know now that we've got a valid nucleotide, and then if the nucleotide is A, we're indented again, and this is the code we do for A. So if nuke is A, I'm going to do rcseek equals T plus rcseek. And what that means is that it's going to concatenate a T onto the beginning of rcseek. If this is the first letter we've come across, rcseek will go from being an empty string to just a T. If rcseek has already got a bunch of things because we've gone through a bunch of letters, it's going to add the T onto the beginning. And then we just need to do this for every nucleotide that we might come across. So if the nuke is A, let's prepend a T. Then we have that elif, which means if it's an A, prepend a T. Else, if it wasn't an A, if it's a T, let's prepend an A. Else, if it wasn't either of those, and it's a C, let's prepend a G. Else, if it was none of that, but it is a G, let's prepend a C. So we deal with every scenario here one by one. Remember, you can read elif like else if. So if our nucleotide is an A, rcseek equals T plus rcseek. Else, if our nucleotide is a T, colon, new line indentation, rcseek is equal to A plus rcseek. Be very careful with the indentation and keeping everything in the same line as I do here. And don't forget the colons on the end of the lines that correspond with if statements or else statements, for example. You may have noticed, yeah, so I snuck a sneaky return statement in here in the case of my invalid nucleotide when I went from one slide to the next. Sorry about that. But if you want, you can include this. This means that if we come across an invalid nucleotide, let's make the function not return anything at all, rather than printing that it's not a valid nucleotide and continuing to do the rest of the nucleotides anyway. So it depends what you want your function to do. If you want it to stop and return nothing when it reaches an invalid nucleotide, you will add this return statement. If you want it to keep going and try and complete the rest, then you might get rid of this return statement and just leave the print statement. It doesn't matter either way. Okay, so after we've done the whole thing for every nucleotide in the sequence, we've prepended the complement nucleotide. What do we need to do? Well, we finally need to return rcseek. Note by this point that rcseek will have contained the complement nucleotide for every nucleotide in our input sequence, so we finished our code, and then we just return that variable. So the output from our function is this rcseek variable. Be very aware of the indentation of this return statement because we only want to return once we've finished the for loop. So we've gone through for every nucleotide in our input sequence, we've done our code, we found the reverse complement, then we return RC-seq. So you've got to make sure that that return statement is in line with the for loop, because we're at the end of the for loop when we run the RC-seq. If you indent that too much, it might do one nucleotide and then return, and you'll have a problem. Okay, so that's great. That code defines the function we need. The final thing we need to do in this file is actually run the function with some inputs and then print the output. So previously I had something like this, but I had it all on one line. Here I've broken it up into 2 lines to make it clear for you. First I want to run reverse comp, which is the function we just wrote, and I want its input to be sys.argv1. Remember, sys.argv1 is the first useful argument. We might be running Python, reverse comp, and then ACGTC. So that AGCGC would be sys.argv1 in that example. So we want to run reverse comp with the first useful argument and store whatever is returned in this mySequence variable. So the RC-seq variable that is returned will be stored in the mySequence variable here. So mySequence will be set equal to the output of that function, and then the final thing we want to do is just print it. So I then have print some string, and I substitute in that mySequence variable into the print statement there. You might want to add some more text around this %s that just says the reverse complement of my input sequence is :space %s. You can format the output however you want. Okay, so that's everything. It runs the script in the second to last line and then prints the output in the final line. So save that as revcomp.py, save it in your home directory, and I'll leave it on the screen, but the way we're going to run it is Python revcomp.py, and then after the py, you're going to put some sequence of nucleotides. And so hopefully when you run that, you see that what's returned is the reverse complement of your input sequence. So the way we were doing it, as I say, if you want it to stop when it reaches an invalid nucleotide, then you can add a return statement after the print statement and just put an empty string there to tell it to return nothing. Or perhaps you want to return some other string. If you want it to keep going, you don't put that return statement there. But that's, as I say, that's up to you, and they will do different things. So try it with a valid nucleotide, try putting an X or something in there that's not valid in this case, and you should see that the X is not a valid nucleotide statement should be printed. Okay, so remember last time I ran the function within the print statement, and this time I didn't. Just to show you how you might do that, you can convert the last line from this into this. There's nothing wrong with doing it this way. It's not going to slow your code down, but just to avoid defining an extra variable that you just use to print, you can actually move the function call, so move reverse comp and then the sys.argv1 into the print statement and substitute whatever is returned from that all in one line. So these 2 lines do exactly the same as this line. The only difference is we don't define the mySequence variable and then substitute it. We just simply put the function call in the print statement, and then whatever is returned from it is going to be printed instead. Neither of those is better or worse, but when you're looking at other people's code, you might find they do that quite a lot.